Number 1, a bus is traveling at a constant speed along a straight portion of road. The equation d equals 30t gives the distance d in feet from a road marker that the bus will be t seconds after passing the marker. How many feet from the marker will the bus be 2 seconds after passing the marker? So much verbiage. Man, they love throwing a lot of words in here to kind of obfuscate. There's a fancy SAT word for you. Or make things unclear, to make it unclear what's going on. The basic formula that's being used here is d equals rt, distance equals rate times time. And they are telling us that the d is distance and the t is the time, which is nice of them. They're telling us that the distance d in feet and that t is seconds. And they say, okay, it's past a marker and this is how fast it's going after it passes the marker. This is how far away it will be, so many seconds away. So the question, how many feet from the marker will the bus be 2 seconds after passing the marker? We just have to make sure, well, first I have to make sure that I've put the correct rate in here of 30, because they did give that to us, the 30. All I have to do is plug in 2 for the seconds, that's my t here, and then solve for d. So d is equal to 30 times my time. My time is 2 seconds. 30 times 2 is 60. So my distance is 60. And that is C. That's my answer. One thing to be wary of this, sometimes they won't tell you the distance equals rate times time. That's what they're talking about. So that's a good formula to know. And another thing to note is this is an early question in this section, so it's unlikely to see any rate conversions happening. But as you get later on in the section, in the module, those may come up. So for example, this may have been how many feet will it be 2 minutes after passing the marker? And they wanted you to check that's minutes and seconds, that the units are different, things like that. That's not the case in this problem, but just be aware of that for the SAT in general, because they love doing that. But there's our answer, C. Number 2. For a particular machine that produces beads, 29 out of every 100 beads it produces have a defect. Okay, so 29 out of 100 are defective. They have a defect. A bead produced by the machine will be selected at random. Can I just say, this machine needs fixing. If you've got 29 out of 100 are messed up, you need a better machine. I digress. A bead produced by the machine will be selected at random. What is the probability of selecting a bead that has a defect? Okay, well, they've told us that 29 out of every 100 has a defect. So that's it. That's our odds right there, 29 out of 100. The only thing that you would have to do in some of these problems is if this was something that could be simplified. If this is a fraction, like say if it was 25 out of 100, you could simplify that down. But this one you can't. 29 out of 100 is just that. So that is my answer, C. Another thing they can do to look out for is they might say, which of them does not have a defect? And you'd be looking for the 100 minus 29, which would be 71 out of 100 would be your odds for that. Look out for those traps, but for this particular problem, they're being straightforward. It is just C, 29 out of 100. Number 3, what is the y-intercept of the graph shown? The y-intercept is where a graph crosses the y-axis, so we just need to be careful that we're looking at the right place. This is the y-axis, and it is even labeled at the top, which is nice of them. But that spot right there is the y-intercept. It is always when x is equal to 0, and then it's 0, 8. When we write things as an ordered pair, the x always comes first, just like in the alphabet, the x comes first, x then y. So 0, 8 is my y-intercept, and there it is. That is D. I'm honestly surprised that they use this -8 and -6 up here. I would have expected them to do something like doing 8, 0 to make sure that you knew that x comes before y. But yeah, we don't have to do any graphing or anything. We just have to make sure that we can read the graph they've presented correctly. Answer is D. Number 4. which expression is equivalent to 2x squared plus x minus 9 plus x squared plus 6x plus 1? This is testing our ability to combine like terms. So I have 2x squared plus x minus 9 plus x squared plus 6x plus 1. These parentheses in this sort of situation, when we're adding or subtracting two groups of terms, the parentheses only matter if this in the middle is a minus. If it's a plus, those parentheses are pointless. They do not matter. You can ignore them. If it is a minus, then you're subtracting everything that's in the parentheses that follow. In that case, my favorite thing to do is to change it to a plus and then change the sign of everything in here accordingly to its opposite. If it was a minus, make it a plus. If it was a plus, make it a minus. And then you get rid of the parentheses. This one, though, they're being nice. We don't have that. So we can just get rid of these parentheses. They do not matter. And we can just start combining like terms. Like terms must have the exact same variables, and those variables must have the exact same exponents. So here we have an x squared. Are there any other x squareds? Yep, there's one. Those two are like terms. If I have two x squareds and I add another x squared, then I have 3 x squareds. And once I've added them together, I like to cross them out so I don't worry about adding them twice. It's also a good way if you have a really long list of like terms, when you get to the end, to find out if you missed anything, if you cross them out as you go, because that's easy to do. All right, our next term here is an x. Do we have any other plain x's? We sure do. There's one. Always look at the sign that's before it. In this case, that's a plus. Sign is attached to it. So I have a positive x and a positive 6x. If I have an x and I get 6 more x's, I then have a total of 7 x's. And I'm going to cross those out. Those are donezo. And then last but not least, I have this constant -9 or -9. I have a constant +1. -9 plus 1 is -8. And I'm at just double check. I've marked everything out. I've combined all the like terms. I haven't missed anything. So my final answer is 3x squared plus 7x minus 8, which is D. Number 5. An analyst collected data on the price of a carton of grape tomatoes at 30 locations selected at random in Utah. Man, they always love giving you these details that really don't matter. The mean price of a carton of grape tomatoes in Utah was estimated to be $4.23. Okay, there's our first piece of really relevant information. The mean is $4.23. All right. With an associated margin of error, the margin of error, my stylus isn't working, I need a new one. Okay, margin of error of 8 cents. Which of the following is a plausible statement about the mean price of a carton of grape tomatoes for all locations that sell this product in Utah? Before I look at the answers, a margin of error means I'm pretty sure that this number that I got is right, but I could have been off. And a margin of error is plus or minus a number. So it might be my margin of error less. It might be that margin of error more. It's somewhere in that range. So I'm hedging my bets. I'm not 100% sure it's 423 because of the things I did in this study, some things that weren't quite accounted for. It might be a little lower. It might be a little higher. There may have been some error, hence the name. So this margin of error of 8 cents means the mean, I think it's 423, but it could be 8 cents less than that. And it could be all the way up to 8 cents more than that. It's going to be somewhere in that range. That's what that margin of error means. So if I subtract 8 cents from that, I get $4.15. And if I add 8 cents to it, I get $4.31. So I'm saying, I think it's somewhere between here. I'm saying it's 423, but it could be as low as 415, as high as 431. It's in there. So let's look at our options. A, it is between 415 and 431. That looks like our answer, but let's look at the others just to be sure. B, it is either less than 415 or greater than 431. Nope. It is not down here or up there. It is right here in the sweet spot in between them. C, it is less than $4.15. Nope, not that one either. And D, it is greater than $4.31. Nope. All right, so we've confirmed A is our answer. It's between 415 and 431. Number 6, 2.6 plus x equals 2.8. What value of x is the solution to the given equation? Okay, anytime we're solving for a variable in algebra, we need to view it like a seesaw, like a teeter-totter. Things have to stay balanced. So anything we do to one side, we have to do to the other side because the sides are equal to each other. We have to keep it that way. So I want to get x by itself. I want to undo what's been done to x, and then I'll just have my x. 2.6 has been added to x. I need to do the opposite of that. The opposite of addition is subtraction. So I'm going to subtract 2.6, but it is a seesaw, a teeter-totter, so I have to do it to both sides. So on the left, 2.6 minus 2.6, that cancels out, and I just have that x behind like I wanted. And on the right, I have 2.8 minus 2.6, which gives me 0.2. And that's my answer. X is 0.2. So you can enter it as 0.2, or you could enter it, if you wanted to be fancy, as 1/5. Not sure why you'd want to do that, but hey, you do you. 0.2 or 1/5 is your answer. Number 7. Out of 300 seeds that were planted, 80% sprouted. How many of those seeds sprouted? Percents are something you can do several different ways. You can do it by hand. You can do it with your calculator, whatever you prefer. This is asking, essentially, what is 80% of 300? That's what we're saying. 80% of these seeds sprouted. How many is that? So when it is this percent of a number, all we do is multiply them. So here it is 80% of 300. So we multiply those together. 80% in decimal form is 0.80. We multiply those together and we are going to get 240. Again, percents are one of those things that, because we're dealing with, they can be written as decimals, they can be written as fractions. Different people have different ways of looking at them. This way of saying 0.80 times 300, that's always going to give you your right answer of 240. Another way you can look at it, this is sort of a more mental math kind of way, is 300 is 3 hundreds, right? Or 3 times 100. 80% of 100 is 80. That's always the easiest one to do, right? 10% of 100 is 10. 20% of 100 is 20. You know, all these, the percents are the same number when we're talking out of 100. So if 80% of 100 is 80, this is 3 times as many. So I multiply that by 3, and I write the number incorrectly, and it is 240. Again, that's just a different way of looking at it. That's a way you can do it in your, if your mind, if it makes sense to you, that often will be quicker than typing it into a calculator. But this isn't a really time-consuming problem either way, so it's not a big deal if you want to do one or the other. Some problems, I'll say please learn to do it this way because this is so much faster and you need all the time you can get. This one, it's what you prefer. They're both about the same amount of time. Number 8, f of x equals 4x plus b. For the linear function f, b is a constant and f of 7 equals 28. What is the value of b? So a linear function, this is a line. That's what linear function means. When we have a function, it means we have an input and an output. X is our input and f of x is our output. So we put a number in for x, we do the math that we're told to do, and the result we get is what f of x is. So when it says f of 7 equals 28, it means they took 7, they plugged it into this equation, they did the math, and the result was 28. So let's set that up, and then we can figure out what b is. So we know it's 4x plus b, and that equals f of x. And we're told that f of 7 is 28. So f of 7, that result is going to be 28. All right, so let's do our math here. 4 times 7 is 28. 28 plus b equals 28. So if I subtract 28 from both sides to undo what's been done to b, because b has had 28 added to it, I will get that b is equal to 0. And that is A. That's my answer. And I accidentally circled B as well. Just A. A is, it's 0. The only sort of thing I can see with this particular problem messing students up is if they get that B is 0 and think like, wait, it's adding 0 to it? That can't be right, is it? Well, in this case, it is. Just do your math, trust that you've done it correctly. Yeah, and that's it. B is 0. Number 9. Right triangles LMN and PQR are similar, where L and M correspond to P and Q respectively. Okay, so they've actually given it to us in the correct statement, correct similarity statement. They've said LMN and PQR are similar, but they didn't write it like this, so we might not be 100% sure. Does L correspond to P? Does M correspond to Q? And does N correspond to R? Because that's what a similarity statement means. It means we have, I have a right triangle, and then I have another right triangle. It may be bigger, it may be smaller, but it is proportionately the same. And we want to know which corners, which points correspond to which ones in the second triangle. And they're confirming it. L and M correspond to P and Q. So L corresponds to P, M corresponds to Q. Okay, so that's all good. Now we can draw this out. We don't have to, but if we want to, it can help us visualize it sometimes. So I'll say L, M, N, P, Q, R. L corresponds to P, M corresponds to Q, and by default, N corresponds to R. Then we're told that angle M has a measure of 53 degrees. What is the measure of angle Q? Well, we were just told that M corresponds to Q, so in similar triangles and similar shapes, the angles are congruent, not the sides. The sides are proportional. The angles are congruent. So if M is 53 degrees, then Q, the corresponding angle in the similar triangle, must also be 53 degrees. Now, I should note here, I drew L and P as being the other acute angle in this triangle. We don't really know that. It is possible that L and P are the right angle, and that N and R are the other acute angles. It doesn't really matter for this problem. This is just to give myself a visual. The one thing I do know for absolute certain, which I have included in this similarity, is which angles correspond to which in the triangles, and also that angle M is one of the acute angles. It's not the right angle, and it has a measure of 53 degrees. So if you are asking in the comments, wait, how did you know L and P were the acute angles? I don't. It is also absolutely possible that it could be like this, where that's R, that's N, that's L, that's P. Those are both possible. But again, not really pertinent to this question. The main pertinent part is they are similar. M corresponds to Q. So if M is 53 degrees, Q is also 53 degrees. And that's my answer. That is B. And just a little side note. for the answers that are provided here, these two answers of being 127 degrees and 143 degrees, both of these are impossible as soon as you find out that they are right triangles. A right triangle, always, 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 the largest angle is 90 degrees. You cannot have an angle larger than 90 degrees in a right triangle. As soon as you've got a single 90-degree angle, since all three angles add up to 180, the other two together must be 90. So if I call this angle A, B, and C, angle C is 90, then angle A plus angle B equals 90 together. 90 is the biggest, the others added together equal 90. So no, it is not possible to have one angle in a right triangle that's 127 or 143 degrees. So just right there, those two would have been eliminated. If you were unclear about, similar triangles and what exactly it meant. Did it mean, does it mean it's the one opposite? Does it mean it's the same? What does corresponding mean? You could have eliminated those right off and got it down to 2. And then you have a 50-50 chance. But yeah, if they correspond, the angles are the same. Answer is B, 53 degrees. Number 10. What is the equation of the line that passes through the point 0, 5 and is parallel to the graph of y equals 7x plus 4 in the xy plane? So equation of a line, and we look down here, they are all written in y equals. So y equals, and I'm going to use mx plus b. That's our slope-intercept form of a line. It's my favorite form for a line because everything's right there. We have x and y, which are our variables. M is a constant, it is our slope. B is a constant, it is our y-intercept. So here we're told we have this line, it passes through the point 0, 5. 0, 5 would be right about there. Hates when I draw dots. It always puts up that little note. Do you want to make a note? You're making a dot. Surely you want to make a note. No, I don't. I'm just making a dot. So I make this dot at 0, 5. And that is going to be the y-intercept where it crosses the y-axis. Anytime the x-coordinate is 0, you have a y-intercept. All right, so I already know my y-intercept is going to be 5. Now, if you took a sneak peek over here and you go, wait a minute, there's only one that has a plus 5 on the end. Is that my answer? Spoiler alert, yes it is. But let's keep going just in case you get a problem that it does not only have one possible answer after you get the y-intercept, excuse me. Okay. So the other thing in here, which is an important thing to know, even if it's not strictly necessary for this particular problem, it says it's parallel to 7x plus 4. So in this line, 7x plus 4, as we said, the number in front of the x, the constant in front of our x is the slope. The constant by itself is the y-intercept. So this constant in front of the x is our slope. It has a slope of 7. So we want it to be parallel. Parallel lines have the same slope. Perpendicular lines, the other one you may see, have reverse reciprocals or opposite reciprocals. I've heard it called a couple different things. So it means, like say, if one had a slope of 3/4, you flip that to make it 4/3, and you make it the opposite. If one's positive, you go negative. If it's negative, you go positive. If it is a whole number, like 7, you treat it like it's 7/1, and that would become 1/7. You make it the opposite, make it negative. That is perpendicular. That's another thing that will come up in these kind of problems. But this one is parallel. It means the same slope. So in this line, this number right here, before the x is our slope, it's 7. So in my equation up here, I replace that m with 7. And now I have my equation of the line. Y equals 7x plus 5, which is b. Again, like I said, eagle-eyed viewers here may have noticed that that's the only one that has a plus 5. So as soon as we have the plus 5 for the y-intercept, it's pretty locked in that that's our answer. Not sure why they didn't have any others that had the +5, but I guess they thought that you might go a different direction in trying to find the equation for that line. But yeah, B there is our answer. Parallel lines have the same slope. That's the key takeaway from this problem, along with your slope-intercept form of a line. Number 11. Which of the following equations is the most appropriate linear model for the data shown in the scatter plot? They love putting in scatter plots into the SAT. This is, I think, a little unusual that it calls it the most appropriate linear model. Usually they refer to it as the line of best fit, because that is what it's called in statistics, the line of best fit. And it's referring to a line that when you draw it through a bunch of dots, that's what a scatter plot is, it's dots showing data. When you draw that line through those dots, it is the line that has the smallest average distance from each point. So it's like the closest you can get to all the lines. Now on the SAT, currently, they do not ever ask you to, on your own, calculate a line of best fit. So you don't have to know how to do that. What they are going to do, so they're not going to give you like a bunch of, these, they're not going to take these dots and put them in a table of XY values and say, calculate the line of best fit. They don't do that. What they do, and this is an easier version, so it's good for you, is they give you a graph of dots and they say, what would be the equation of a line that would go through that? And it's not going to be subtle. It's not going to be like one says y equals negative 1.8x and one says y equals negative 1.9x, and you have to determine which of those is the better line of best fit. Not even a little bit. It's going to be very broad strokes. It will be either a positive or negative slope, and then either a positive or negative y-intercept. If you can identify, if I draw a line like this, is that a positive or negative slope, and does it have a positive or negative y-intercept? And it won't be close. It will be very distinct. And that's what we have going on here. See, as you can see, we have two answers that have a negative slope, two answers that have a positive slope. All the numbers, 1.9, 1.9, it's all the same. And for the y-intercepts, we have two that have negative slopes, and I have two that have negative y-intercepts and two that have positive y-intercepts. So that's all we have to determine. All the numbers are the same. And just as a review, in case you missed the previous question, y equals mx plus b, that's our slope-intercept form. M, the number by the x, is our slope. B, the number that's by itself, that is our y-intercept. Okay, so slope being positive or negative. Think of it as how you read if you're going left to right. In English, we read from left to right. So if you're going up as you read, you're going up towards the future. The future is bright. It's positive. We're going up towards the positive y. It is a positive slope. If, as we go left to right, we're going down. Oh, I'm going down. I'm feeling down. It's negative. Got negative feelings. I'm feeling down. I'm going down. You are going towards the negative y. That's a negative slope. If you are questioning yourself on the day, you can always pick a couple of points and do a test. So if I draw this line, then I might say, okay, 2 points that are on the line, that looks like it's kind of on the line, and that looks like it's kind of on the line. I'll take those 2 points. It's rise over run, like how far it goes up or down, over how far it goes left or right. So it's going down 2. So the rise, it's a negative rise, it's going down 2, and it's going to the right about 1. So negative 2 over 1, that is negative 2. You can also, the equation you'll also see in your math class is y2 minus y1 over x2 minus x1. It's where you pick those points and plug them in. So this first point would be 3, 5, and the second point is 4, 3. On my little approximate line, I can plug those in, and I would get 5 minus 3 from there over 3 minus 4, and that gives me a positive 2 on the top and a -1 on the bottom, again, I get -2. So any of these ways, either just looking at it or counting it on the graph or doing the slope formula, they're all fine, whatever works best for you. So all three ways concur. This is a negative slope. As we go left to right, it is going down. That's a negative slope. So that eliminates C and D because they have positive slopes for that number that's by the x. Now we just need to look at the y-intercept. Is that a negative or positive? Well, we're going 0 and then we're going up. This is the positive y. Down here below 0 would be the negative y. It's going to be intercepting up here near +10. So that is a positive y-intercept. So B, with a negative slope and a positive y-intercept, that's my answer. So yeah, don't get too worried about the ones that are lines of best fit. Again, you will not have to calculate it from scratch by looking at a table of data. They're dressing it up by saying it's a scatter plot and what's the linear model and the line of best fit. And it really just is, hey, you know how this kind of looks like a line? Does that line have a positive or negative slope? And does it have a positive or negative y-intercept? That's all they're asking. If you got that, you're good. Number 12. A model predicts, this is a scientific research model, not a fashion model. A model predicts that the population of Bergen was 15,000 in 2005. The model also predicts that each year for the next 5 years, the population P increased by 4% of the previous year's population. Which equation best represents this model where x is the number of years after 2005 for x is less than or equal to 5? Okay. Population growth equation. They use this a lot. A lot. Okay, and so it's population equals, and then this first number that's in front of the parentheses, and then we have a number inside the parentheses, and then we have this x up here. Okay, they're going to use this a lot. This number that goes right here is your starting point. It's the starting population. The number that goes here is going to be representing your percent of change, whether that's an increase or a decrease. And this number up here is units of time. There are more complicated versions of this, but this is the version that seems to show up in the SAT. Just a starting population is outside the parentheses. You're multiplying it by a percent of change, and it's going to be usually in a decimal form, and it's over time. Okay, so percent change. This is going to be 100% or 1 plus or minus, depending if it's an increase or decrease, the percent of change. So this is the population increased by 4%. So it's 1 plus 4%, 1 plus 0.04. Not minus because it's an increase. So it's minus would be a decrease. Our starting population is 15,000. Tells us right there. 15,000. Okay. 1 plus 0.04 is 1.04. And they told us to just leave x by itself because x is the number of years. Now the reason this works, think about if I expanded this. Like why does it work to have 15,000 times 1.04 to the power of x? It increased by 4%. Okay, so in the first year, it would look like this. 15,000, if you were just doing this manually, right? You didn't have this little formula. You'd say, okay, in the first year, it increased by 4%. So I could multiply 15,000 by 4% and then add that to 15,000. But the simpler way is just to multiply it by 1 plus 4% because the 1 is getting multiplied by 15,000. And then that 0.04 is getting multiplied by 15,000. So it's the same as saying 15,000 plus 15,000 times 4% or times 0.04. So it just takes care of it all in one. So that would be my first year. Then the second year, I take my result that I got when I multiplied 15,000 by 1.04. So the second year, I would multiply it by 1.04 again. That's the second year. Then the third year, I would take that and I would multiply by 1.04 again. So it's essentially, I can remove these parentheses because it's all just being multiplied. So it'd be 15,000 times 1.04 times 1.04. That right there is the same as 1.04 squared. Hey! Second year, and I multiplied it by 1.04 squared. 1.04 to the power of the number of years. That's why that works. All right, so we've created our equation, and there it is, 15,000 times 1.04 to the power of x, and that is D. This is a good equation to know when you're dealing with interest and compound interest on the SAT, which is very similar to this. It's a percent of increase, and it's compounding. For those, when it is specifically interest, a lot of times they will give you the equation. They'll give you the interest formula and say, this represents that, that represents this. A lot of the time. There have been a couple times I've seen where they haven't, but usually they do. For the population increases, they don't. They expect you to know this basic thing, and I know I'm not using the variables for it. I just think it's important just to kind of remember it. So you start at the starting population. Inside here is the percent increase or decrease, and up here it's the time, months, years, however it's increasing. If it's increasing every year, it's increasing every month, however many units of time that you're increasing by. But this is very important to know. It shows up all the time. All right, on to the next one. Number 13. 2a plus 8b equals 198. 2a plus 4b equals 98. The solution to the given system of equations is a, b. What is the value of b? You absolutely can do this through graphing if you'd prefer. Me, I look at it and I go, I think I can do something here that's even a little faster. And I'm all about speed when it comes to the SAT. I don't want to waste any time I don't have to. So as we're taking the SAT, we need to know ourselves. We need to know what's the fastest for us. So I look at this and I go, hey, they don't want me to know A and B, only B. So is there a way I can solve this quickly where I find out just B, that I don't have to type this in and, find it? I don't have to. Well, if we use elimination for a system of equations, we want something to cancel out. So either the A's or the B's would need to cancel out, and it would leave the other variable in a single variable equation, and then we can solve it. Well, these right here, they are already very close to being able to cancel out. One of them needs to be negative, right? So 2a and negative 2a would cancel out when I add those together. I don't have to go through of like multiplying this by a variable or by a constant, and changing everything. I don't have to do that. I can just multiply everything on the bottom by a negative. Things will cancel out. It'll be great. So, okay, I'm going to do that. I'm going to multiply everything on the bottom by a -1. That makes that a negative, that a negative, that a negative. Boom. Now I add them together. Those cancel out. 8b and a negative 4b is just 4b. And 198 minus 98 is 100. I go, okay. And I don't need to get my calculator out for this one personally because I go, 4 goes into 100. I know this one. So 4 times b equals 100. I want to undo that. I divide both sides by 4. So on the left side, I am left with just b, and 100 divided by 4 is 25. So for me, when I look at that, I go, oh yeah, those are going to cancel out. And then 8b minus 4b is 4b. 198 minus 98, I can do that one. There's no carrying of digits or anything like that. They just drop. It gives me 100. I can do that. I can move on. This is one of those problems too that you might choose to do it this way, and then at the end, if you have any extra time, you might choose to come back and put it in your graphing calculator to check your work. It's not a bad idea to check your work, and if you check it in a way other than the way you did it, So I would say also, if you chose to do this with a graphing calculator and you have time at the end, come back and do it manually and see if you get the same answer. Because you can very easily type something wrong into a graphing calculator and get the wrong answer. It's happened to all of us. And that's especially dangerous on this one because there are no answers provided. So if you get an answer, let's say you typed something wrong in and you get that b equals 21.3, you have no choices here that would direct you to go, oh, 21.3 isn't there. I typed something in wrong. Ugh, yikes, I need to redo this. There's nothing here to catch that error. So it's not a bad idea to check your work, come back later and do it manually, or even just type it into the graphing calculator again so that you can get the right answer, which in this case is that b is equal to 25. Number 14, the expression 90y to the fifth minus 54y to the fourth is equivalent to r times y to the fourth times 15y minus 9, where r is a constant. What is the value of r? There's something subtle that might be a trap for some students here. It looks like they're telling you to take out the greatest common factor. They are not. Why do I say that? Because they pulled out r times y to the fourth, but they left behind 15y minus 9. 15 and 9 are both divisible by 3. So you could pull a 3 out of that, and you'd be left with 5y minus 3. So whatever they pulled out, r, that is not the greatest common factor. I can absolutely see students doing the work and figuring out what the greatest common factor is, and then putting it very confidently, and then they've got it wrong. Like, what? No, they didn't pull it out. They pulled out something else. So we got to be very careful. So we have 90y to the fifth minus 54y to the fourth. That's an odd looking minus. And they pull out r times y to the fourth, which leaves 15y minus 9. Okay, so the y's they have pulled out. They pulled out y to the fourth out of y to the fifth, leaving a single y. And then this, they had a y to the fourth. They pull out y to the fourth. It leaves no y's behind. All right, so now we just need to look at this constant. They pulled it out of 90 and left 15 behind, which that may not be a multiple you know offhand, but the second one I'm hoping that you're familiar with is out of 54, they pulled something and it left 9. So 9 times what would equal 54? That's 6. 9 times 6 is 54. And you can double check that. Is 6 times 15 90? Yes, it is. And that's it. That's our answer. Our answer is 6. That's all they're looking for. Again, asking, because what they really are asking is 9 times what equals 54? So that's not a very hard question, right? But again, where the trap lies is making you think they pulled out a greatest common factor, and then independent of this, not looking at that, if you tried to find the greatest common factor of that, you're going to get 18. Because 18 times 5 is 90, and 18 times 3 is 54. You're going to get that 18 is the greatest common factor. You'll be like, it's 18. Nope. They didn't pull out the greatest common factor. They pulled out a random number, and that was 6. 6 is our answer. Number 15. The graph of y equals f of x is shown, where the function f is defined by f of x equals ax cubed plus bx squared plus cx plus d, and a, b, c, and d are constants. For how many values of x does f of x equal 0? A lot of text. They love putting all the text. Don't let all that text confuse you. The focus here should be the graph. And what does it mean when we say when f of x equals 0? It means I plugged a number into my equation. I did all of this math. I plugged x in everywhere there was an x. I did all the math, and my output, my result, was 0. So that would be my y value. X would be x, y is 0. Where is y 0? On the y-axis here. So when they're asking how many times does f of x equal 0, if we're looking at a graph of a function, all they're asking is how many times does it cross the x-axis? That's it. Here it crosses it 3 times. There are multiple names for this. Be aware they may say different things. They may say, how many zeros does this function have? They may say, how many solutions does this function have? How many x-intercepts does this function have? Or here again, they may say, how many times, for how many values does f of x equal 0? These all mean the same thing. They like to use all of these interchangeably. If you are graphing, if you're either given the graph or you're allowed to graph it, it just means how many times do you see it cross or touch. It can just boop, touch. That also counts. Cross or just touch the x-axis. That's what they're asking. Here it is 3 times. My answer is C, 3. Number 16. The area A in square centimeters of a rectangular cutting board can be represented by the expression W times W plus 9, where W is the width in centimeters of the cutting board. All right, I'm going to draw this just so I can see what's going on. So I've got a rectangle, and I'm told W is the width. Yeah, I'm going to draw it more like this because I tend to think of, I admit, when they say length times width, I'm always like, well, which one's which? It doesn't really matter. But I'm going to call width this one. I think that's the more common way. Base and height, yeah, I never get those confused. But length and width, I'm like, I don't know why I've always had that blind spot. So that is my width. And we're told the area is width W times W plus 9. Now, area of a rectangle is going to be length times width. So since this area is width times this bit, I know this is representing my length. So W plus 9, which expression represents the length in centimeters of the cutting board. Okay, well, there we go. W plus 9 is my length. Variations of this problem include what is the perimeter of the cutting board. That one's pretty common. If you get one that asks that after you figured out what the length and the width is, you would add all these sides together, and you would know, since the sides, opposite sides of a rectangle are congruent, that this side would also be W and this side would be also W plus 9. In that kind of problem, then your answer might be presented as 2W, those two together, plus, and they might multiply those, W plus 9 times 2, and you would distribute and say 2W plus 2 times 9 is 18. Combine like terms, 4W plus 18. They also can leave these in undistributed form. They sometimes do that. They might say 2W plus 2 times W plus 9. This is why it's good to know your area and your perimeter, and also know like terms and know distribution, distributive property, because you never know how they're going to present an answer and what variation they're going to do. But this one, they were being nice. It is just the straightforward. If W times W plus 9 is the area and W is the width, W plus 9 must be the length, because area is equal to length times width when we're talking about a rectangle. Again, that means my answer is D, W plus 9. 17. P equals K over 4J plus 9. The given equation relates the distinct positive numbers P, K, and J. Which equation correctly expresses 4J plus 9 in terms of P and K? Anytime we have this expressing X in terms of Y, expressing W in terms of Z and G, whatever, what they're asking is to get the term, what they're asking to express by itself. So like if this had been which correctly expresses K in terms of P, 4J, and J, they would want K by itself and everything else on the right. This one's a little different. They're not picking a single constant that they want on the left. They're saying they want 4J plus 9 on the left and everything else on the right. So we need to manipulate things using our algebraic knowledge so that 4J plus 9 is by itself, and P and K and anything else if there is Any other constants, if they happen to be in that particular problem, will need to be on the right. That's how you're going to do it. You're not solving for the constant. It's impossible. You only have one equation and you have multiple constants. The shorthand for that is if you are trying to solve for it, you need as many equations as you have constants. So if there are two constants that you're solving for, two variables that you're trying to figure out what those variables are representing, what constants they represent, you have to have two equations. 3 variables, 3 equations, just the way it works. Here we only have one equation. You can't solve, you just move. So how do we do this? How do we move 4j plus 9? I'm going to treat 4j plus 9 as a whole unit because that's what I'm solving for. I don't have to split them up. So this is k divided by 4j plus 9. Anytime the thing that you are solving for is in the denominator of an equation, you got to get it out of that denominator. And that's going to involve moving it to the other side. Sometimes people get stuck on this. They get stuck on it because they're thinking, I need this to stay on a side. How do I move k over? No. You need to move this over and then you move the p back. Here is a truncated version so you can see what's happening a little more simply. A equals b over c, and I want c by itself. I can't get rid of the b because c is in the denominator. I have to move the c. So I multiply both sides by c, and that gets me to a times c equals, those cancel out, just b. And now I can divide both sides by a, and that moves that a over to the right because these cancel out. And I am left with c is equal to b over a. That's always the process when the item you're solving for is in the denominator. So let's do that up here with 4j plus 9. I'm going to multiply both sides by 4j plus 9. I love the ones where it's in the denominator because those tend to throw students off. So then on the left, make this a little darker green, I have p times 4j plus 9. Those canceled out on the right, so I just have k. Now 4j plus 9 is being multiplied by p, so to undo that I divide by p. Divide both sides by p. Always in algebra we do it for both sides, keep it balanced because it's an equation, got to be equal. And I've reached my goal. I have 4j plus 9 on the left, which is what I wanted, and k divided by p on the right. And that is A. There's my answer. Again, it's not uncommon for them to go further and say, like, what is J in terms of K and P? This one, they're being nice. If that happens, if it was something like that, if they had asked for, J by itself, you would still go through this process. You would still get to this point, and then you just keep going forward. You would subtract 9 on both sides to get rid of that. And then after you've done that, you would divide by 4 on both sides. Another way of doing that is multiply by 1/4 because we got this fraction over here. That's probably the way I would go. And that would get rid of the 4 and the 9, and you just have the j. But yeah, anytime, if it's the j, it's the 4j plus 9, whatever it is, if it's in a denominator, this is the process you go through. You multiply both sides by it to get it out of that denominator. That moves it over to the other side, and then you get rid of anything else that's left to get it by itself. And our answer is A. Number 18. Circle A has a radius of 3n, and circle B has a radius of 129n, where n is a positive constant. The area of circle B is how many times the area of circle A? There's 2 ways you can look at this. I'll show you both of them, see which makes more sense to you. So I have this circle right here. It has a radius of 3n. And then I have this other one. I am not drawing this to scale because I can't. And this is circle A. And over here I have circle B. It has a radius of 129n. Area of circle B is how many times the area of circle A? Well, the formula for area of a circle is pi times the radius squared. So what would the area of circle A be? It would be pi times my radius squared. 3n squared, it means I square both of those since it is 3n times 3n. So 3 times 3 is 9. I'm going to write it in front here. And n times n would be n squared. Now b, 129n, we're going to do the same thing. It's pi r squared. So pi times 129n squared, or 129n times 129n. 129 times 129 is 16,641. And I'm going to scoot this little pi over here because I didn't give myself enough room. And n times n is n squared. So how many times is the area of circle B of circle A? I said that weird. The area of circle B is how many times the area of circle A. What did I have to multiply this area by to get to that area? Well, I didn't multiply the n squared or pi by anything because they stayed the same, right? So all I have to do is I multiply 9 times what to get to 16,641. So 9 times my unknown number. We're dealing with circles. I'm going to call it C. So 9 times C is equal to 16,641. So I need to divide both sides by 9. And when I do that, I get 1,849, which is D. And you say, like, oh, what's the shortcut then? Because that didn't take too long, right? That wasn't a really lengthy process compared to some of the other problems we have. As long as we know what we're doing. Well, here's the fun thing is if you know what you're doing, because this kind of problem, I've seen it more than once. So it's not just a one and done. It does show up. They like this where they give you 2 radii and they say, how many more times is this than that? Because you are squaring, if you notice, like these didn't matter, right? The variable squared and the pi, we were only concerned with this 9 and this 16,641. And we said 9 goes into this how many times? That was essentially what we were asking. Well, because you know, now that you've done this, you know that the variable and the pi are kind of irrelevant when you're saying how many times bigger is it if they are the same variable. In this case, they are. N and n, they're the same. So really, it's only the 3 and the 129 that are the same, that are necessary for us to look at. And we're going to square both of them. So it's 129 times 129, that's our squared, and we're going to be dividing that by 9, which is 3 times 3 squared. So what you can do is you can just say, without going through this process of squaring and then dividing, this is 129 over 3 times 129 over 3. You can just do this part, 129 over 3. And 129 over 3 is 43. And then you know it's going to be 43 times 43, which is 43 squared. So it's slightly fewer steps in your calculator. By what I mean is if you know this, random ruler, as I meant to get my eraser, if you know this, that it's going to be 129 divided by 3, and then you square it, so it's how many more times is the radius, and then you square it to find how many more times the area is, you wouldn't have to say what's 129 times 129 and get that and then say, okay, what's 3 times 3? That's 9. Then divide that number that you got by 9. You can just do the little quick shortcut of saying in your calculator 129 divided by 3, and then you hit squared and you have your answer, which is 1,849. If that makes more sense to you, use that. If you just said, Alyssa, why did you show me that? I don't like it. Then don't use it. This is what we want. We want for you to understand the math. Because this exact problem is not going to show up on the SAT. A variation of it? Absolutely. Quite likely, in fact. It shows up a lot. So if you understand the underlying math and what's going on, you can pick the method that makes the most sense for you, that you're going to remember, so that whatever variation you get, you can do it. So whichever of those two methods makes more sense, go for it. Number 19. The measure of angle R is 2 pi over 3 radians. The measure of angle T is 5 pi over 12 radians greater than the measure of angle R. What is the measure of angle t in degrees? You can, if you have a calculator that converts radians to degrees, you can convert all these to degrees and then convert back. That's definitely a method to do it. Yeah, I'm going to show you my preferred method because, hey, it's my channel, right? So I'm showing you the way I prefer. I'm going to just deal with the math first and then convert one time. All right, so R, come on, right, is 2 pi over 3 radians. T is 5 pi over 12 radians greater than angle, the measure of angle R. So R is 2 pi over 3 radians and T is angle R, 2 pi over 3 plus 5 pi over 12. So I'm going to just add these two fractions together. 2 pi over 3 plus 5 pi over 12. I need to have common denominators there. So to convert 2 pi over 3, this is thirds. We're treating it as just a plain ordinary fraction. We need to convert it to twelfths so we can add them. So 3 times what equals 12? That's 4. To convert a fraction, we multiply by the same number top and bottom. We can do that because 4 over 4 is 1. If I multiply something by 1, it doesn't change it. So I'm going to do that. I'm going to multiply on top. I get 2 pi times 4 is 8 pi. The pi just stays. We just multiply the constants. On the bottom, 3 times 4 is 12. Okay, so I'm going to replace this here. Instead of 2 pi over 3, it is 8 pi over 12. And then I can add them. And when I add them, 8 pi plus 5 pi is 13 pi. And that is over 12. All right, so that is my measure of angle t. It is 13 pi over 12. Let me erase this, give myself a little room. All right, so 13 pi over 12, and I want to convert that to degrees. All right, when we're converting radians to degrees and vice versa, we're going to be multiplying by either 180 over pi or pi over 180. So if it has the pi in it, if we're converting to degrees, our degrees that we are using in our high school math generally does not have pi in it, and it's a larger number. You know, you have like 90 degrees, 95 degrees. Those are 30 degrees, 180 degrees. These are the more common ones we're dealing with in high school math. Not 1. You can have 1 degree, but, you know, less than 1. So we want, if we're converting from radians to degrees, we want the pi's to cancel out, right? And if we're going from degrees to radians, we want to add a pi. So which of these two would I multiply this by to get rid of the pi? It would be the one with the pi on the bottom. Then the pi's cancel out, and the number I'm going to get is going to be pretty big because it's 13 times 180, and then you divide that by 12. So 13 times 180 is going to be 2,340, and then 12 times, because these are just 1 now, 12 times 1 is 12. When I divide 2,340 by 12, I get 195. And that is C. You also absolutely, again, if you had a calculator that will do it, you absolutely could have converted this into degrees and then convert that into degrees and then add those degrees together. You would still get 195. If you're doing this manually, I don't recommend that. That's more work. I would recommend adding this together and then converting at the end. I think that's a little less. Yeah, granted, with this one, you do have to change that 2 pi over 3 into 8 pi over 12. For me, it's a little faster to do that than to convert both of these by hand to degrees and then add them. But you absolutely could. And it's just lagging. It does not want me to write. You know, same thing would work. 180 over pi. Pi's cancel out. And if you wanted to put this back into its 2/3 to make it a little easier, and then you could cancel again. 3 goes into 180 60 times, and that's 1. 2 times 60 is 120. Also, if you know, like your radians, you know, like you know for the unit circle, if you know what the radian ones are, that can help for the 2/3 pi. For the 5 pi over 12, It's generally not on there in the ones that the students are given, the ones my teachers gave me anyway. So we have that first one's 120. And then the 5 pi over 12, you can do the same thing, times 180 over pi. Pi's cancel out. 12 and 180. Yeah, that does go in there. It goes in there 15 times. So it's 1, that's 15. Then 15 times 5 is 75. And what is 75 plus 120? 195. Ding, ding, ding. So yeah, there's multiple ways you can do it. Do what's fastest. Do what's most comfortable. Do what you understand. Number 20, y equals x squared minus 14x plus 22. The given equation relates the variables x and y. For what value of x does the value of y reach its minimum? Can you do this by graphing? Absolutely. Do I recommend it? Nah, I think there's another way that's faster. I just do. And time is of the essence on the SAT. We always want as much time saved as possible. If you decide to graph it, that's fine. It's not going to take you forever. It's just, it's a few seconds longer, but it's not a big deal in the grand scheme of things, but I'm going to show you both ways. So if you have a graph and you're trying to find where it reaches its minimum, and we know it's a minimum because this first x squared is positive. That means it's a parabola. An x squared is a parabola. Positive x squared means it opens up. If this were a negative x squared, it'd be opening down, and then we would have a maximum, not a minimum. So, okay, that minimum point is going to be the lowest that it goes. So wherever this parabola is, wherever it turns up when you graph it, you're going to look at that minimum point, be absolutely sure that you've identified the minimum correctly, and see what the x value is for that coordinate. We want the x. One thing to watch out for in that case, which I've seen them do, I don't know if it's true in this one, but just FYI, I've seen them do where the minimum is very close to like a 0. Like say, if you were to like zoom way in and it turns out like the minimum is right there, but then there's a 0 right there. And sometimes students try to highlight and they see that dot that's highlighted and they highlight the wrong one. I've seen them do that to be sneaky like that. So just be careful when you're using the graph. The way that you can do this mathematically, that is frankly super fast. The formula for the axis of symmetry, that would be a line that splits a parabola right down the middle that goes through its maximum or minimum, is x equals negative b over 2a. And they're wanting the value of x. They're not wanting the value of y. So we wouldn't have to do any more math. We just plug in the numbers for negative b over 2a and we'd have our answer. And what does that b and a mean? It's referring to our sort of standard of a quadratic, which is that y, y equals ax squared plus bx plus c. That format. This is our a, it's the constant in front of the x, and this is our b. And this does connect with whatever sign is in front of it. If there was a negative here, it'd be connected with that. So in this case, our a is an invisible understood 1. That 1. Boop. And our b is a negative 14. So this right here, when it says negative b, it means the opposite of b. Since b is a negative 14, the opposite of that would be a positive 14. 2 times 1 is just 2. 14 divided by 2 is 7. 7's my answer. That's it. It's the axis of symmetry. It goes through the minimum, and it's the x value of the vertex, all in one. So you tell me, like if you knew this, if you had this formula very solid in your head, and you're given this problem, what is going to be faster? Is it going to be faster to get out your calculator or go to Desmos and type in y equals x squared minus 14x plus 22? Let me double check, make sure I entered it correctly. All right, let's look, let's highlight the point. That doesn't take forever, but is that faster? Or is it saying, oh, I know this is negative b over 2a. Negative b here would be 14. 2 times 1 is 2. 14 divided by 2 is 7. Me, I think that's faster. This is why we learn a bunch of different ways. So no matter what the problem is, we always have a tool in our arsenal that we're comfortable with that we can use. Number 21. A small business owner budgets $2,200 to purchase candles. The owner must purchase a minimum of $200 to maintain the discounted pricing. If the owner pays $4.90 per candle to purchase small candles and $11.60 per candle to purchase large candles, what is the maximum number of large candles the owner can purchase to stay within the budget and maintain the discounted pricing? All right, so I'm going to call small candles S and large candles L. So he must purchase a minimum of 200 candles. That's my first thing that I'm given, is that his purchase of small candles and large candles together has to be at least 200, a minimum of 200. So this combo must be greater than or equal to 200. It could be 200, it could be more, it cannot be less. There is my first equation. So I've written that in. I'm going to mark it out. I don't need it anymore. If the owner pays $4.90 per candle to purchase the small candles and $11.60 to purchase the large, what's the maximum number? Okay, so my next equation is going to incorporate those things. It's $4.90 or 4.9, I don't need that zero, for every small candle. And then he's going to spend $11.60, 11.6, don't need that last zero, times the large ones. That's how much he's spending. And when he adds that together, he has a budget of $2,200. So he can't go over that. That's what a budget means, right? So it has to be less than or equal to, he could spend the whole amount, $2,200. All right, now I've used everything. I've got the $2,200, $4.90, $11.60. Okay, now I want to have this. Absolutely, I'm going to say this has to go in Desmos. Now that I've written everything, I've got these two inequalities, and I need to find the maximum where they're intersecting and stuff. No, it has to go into Desmos. So for Desmos, it needs to be x's and y's. So I'm going to say that my small are x and my large is y. I may not have needed to do that. I don't like, jumping the gun, but as soon as I know that, I'm like, okay, this needs to be x and y. And I want to remember which is which. Okay, so now that I have this, absolutely, I need to put this into a graphing calculator to get my answer. So let's do that. Let's go to Desmos and put this in there. All right, so I've got my two equations. X plus y is greater than or equal to 200, and 4.9x plus 11.6x is less than or equal to 200. The solution to this is this area over here where they overlap, because it has to be true for both of them for this to work. So anywhere in here or on the line, because it's equal to, that's why we have solid lines, less than or equal to, greater than or equal to. So what is my maximum for my large candle? My large candle is represented by y. So I want the highest point in this graph that's still a solution. And that's going to be this point of intersection. That's the highest that this double shaded triangle goes. This is the highest point right here, that point of intersection. And what is my y value there? It's 182.08955. Can I buy 182.08 candles? Not in this scenario. We cannot. We cannot buy, less than 1/10 of a candle, please. And then I want 17.9 of the small candles. No, we don't want that. So we want 182. Go one down. That's the most we can buy is 182 large candles, my y value. And that's my answer, 182. Yeah, don't even try to do this one manually. Just don't. Trust me on that. I mean, we got these huge numbers and stuff. 100% this is, I would not recommend you do it any other way but graph it. But just make sure that you don't enter 182.08 or 0.1 on there, because this is an input question, right? We don't have choices. We are inputting it. Don't put in 182.09 or 0.1, whatever, what have you. We want to say reality. These are whole candles. So it's just 182. That's the maximum number he can purchase. Right, number 22. Y is less than or equal to x plus 7, and y is greater than or equal to negative 2x minus 1. Which point xy is a solution to the given system of inequalities in the xy plane? When you are trying to find a solution to a system of inequalities, there's 3 different ways you could do this. And which one is the fastest is going to be up to you. Because this is multiple choice, we have these 4 points here. You absolutely, if you wanted to, you could plug each of these points into these 2 equations and see which pair, which ordered pair, which point makes both of these statements true. So you could do that. You can say, okay, for y is less than or equal to x plus 7, you could say negative 14 and 0. Plug in negative 14 for x, 0 for y. Is 0 less than or equal to negative 14 plus 7? Well, negative 14 plus 7 is negative 7. Is 0 less than or equal to negative 7? No. A is out. Then you can say, okay, what about 0 and negative 14? So I plug in 0 for x, negative 14 for y. 0 plus 7 is just 7. Is negative 14 less than or equal to 7? It is, so B is a possibility. All right, C, 0 and 14, 0 for x, 14 for y. Is 14 less than or equal to 0 plus 7 or 7? No, 14 is greater than that, so C is out. And then last but not least, we have D, where x is 14 and y is 0. Is 0 less than or equal to 14 plus 7? Yeah, 14 plus 7 is 21. 0 is less than or equal to that, so it could be D. Now we just have 2 options. And we have that y is greater than or equal to negative 2x minus 1. We can plug in either of these 2 options. It doesn't matter. I'm going to pick the one that puts in a 0 in for x to get rid of that negative 2. Why not? Because see, if this does work, then I know B is my answer. If it doesn't work, I know D is my answer. I'm plugging in the points for B, where y is going to be negative 14, and negative 2 times 0, which is just 0, minus 1. Is negative 14 greater than or equal to negative 1? No, it is not. That would make my answer D. Can you do it that way? Absolutely. You totally can. And depending on your math proficiency or like plugging things in, it may not take you that long to figure out that D is the answer. The other way you can do this is through graphing. You're going to input both of these into Desmos, and here we go. I have them both here already. Y is less than or equal to x plus 7. Y is greater than or equal to negative 2x minus 1. And the area that you want is you want somewhere in this shaded area. Now, the 4 points that they gave, you can do this a couple ways. You could enter all these points here and see which one is in that area, or you can just look at the graph itself. If you're, let's see, if there's 14, 0, then negative 14, 0, 0, 14. I'm not putting them in the order that they were in the A, B, C, D. Sorry about that. I'm just inputting them. There we go. Okay, there's our 4 points. And so, there we got our negative 14, 0, 0, negative 14, 14, 0, and 0, 14. And 14, 0 is the only one that is in the shaded overlapping area. Because this all blue that changes over here as it overlaps, this is the y is greater than or equal to negative 2x minus 1. Let's turn off. See, it's that one. So it's a line, negative 2x minus 1, and it is drawn as a solid line because it is greater than or equal to. Anytime we have these inequalities, it's showing all the possible solutions, all the ordered pairs in the universe that would make this statement true. Anything in this blue will make this statement true. Any point that I pick, like here, 0, 10, or 10, 10, or 1, 1, or 2, 2, or any point like that that's in this blue, it could be down here, be up here, wherever, it will make this true. So the blue shaded area is representing the greater than, and the equal to is the line itself. All these points on the line would make y equal to negative 2x minus 1. If this was just y is greater than, I did double, there, it would be a dotted line because it's everything up to that line, but it doesn't include it. So it has to be that equal to. Then we have our other one, the red one. here, which is y is less than or equal to x plus 7. We have the line y equals x plus 7, and then everything below it. Everything that's in here is in the red, would make this a true statement, and everything that's on the line is where y is equal to x plus 7. So the shaded is where y is less than x plus 7, and the line, which is included, is where y is equal to x plus 7. So the solution would be where they overlap, and the only one that's in that area is 14, 0. So that's going to be our answer again, D. We got the same answer. Woohoo! And last but certainly not least, the other way you can do this, probably not going to be the way you choose to do it on the SAT, but you know, it just depends on you as a person, how fast you are at different things, what you're most comfortable with. You can do a quick sketch. I would not recommend drawing a detailed graph. Like, I'm not going to use the graph paper that's in the background here. You can do a quick sketch, and if you're very familiar with lines and how to graph things, it's not going to take that long. So I'm doing this to represent 5, 10, 15, 5, 10, 15, negative 5, negative 10, negative 15, negative 5, negative 10, negative 15. And this is not to scale, but it's going to give me a quick idea. So if I'm sketching this out, y is less than or equal to x plus 7, I know my y equals mx plus b formula, which this is very close to it. I know it's an inequality, but we start by graphing the line as if it was just a regular line. In this case, m is the slope, b is the y-intercept. So here, 7 is the slope, and that invisible understood 1 is, did I say 7 was the slope? I'm sorry, 7 is the y-intercept. Correct that if I said that wrong. And the invisible understood 1 is the slope. So that would mean it's crossing somewhere around there, and a slope of 1 means up 1 over 1, like up 1 over 1. So it's going to be about exactly a 45-degree angle, not about. Makes exactly a 45-degree angle. And when you have inequalities for lines, if it says less than and it's not a vertical line, it's going to be beneath it. Everything beneath the line is where you shade. If it says greater than and it's not a vertical line, everything above it is where you shade. And this extends to less than or equal to and greater than or equal to. With other polynomials, when we are doing less than or equal to, greater than or equal to, like if it's a quadratic, like y is greater than or equal to x squared plus 3x, etc. In that case, I always recommend using a test point is the best way to do it. You absolutely could use a test point here as well. You could pick a point. I like 0, 0 if it's not on the line. Plug it in and see if it's true or false. If it's true, that's where you shade. If it's false, you shade on the other side. So here, plug in a 0 for y and a 0 for x. Is 0 less than or equal to 0 plus 7 or 7? 7. Is 0 less than 7? Yes, it is. So I know I'm shading below there. I can use that again if I forget that with lines less than or equal to, we shade below it. So, okay, so just right there with that little quick sketch, because I'm like, okay, it's x plus 7. That's what it's going to look like. It's less than, so I'm shading below it. I've already eliminated the 0, 14. That one's out. And I've already also eliminated the negative 14, 0. That one's out. So just like with the plugging in method that we used for the first round, it eliminates A and C right off the bat. Then we have our other number, our other inequality. When I say number, I don't know. Our other inequality, y is greater than or equal to negative 2x minus 1. So it has a y-intercept of negative 1 and a slope of negative 2, which we could write that as negative 2 over 1. So it's going down 2, then to the right 1. Because this is our rise on top, up or down, and this is our run on the bottom, left or right. Change in y over change in x. So in this case, negative 2 and 1. And you're like, but Alyssa, could it be 2 over negative 1? Yeah, it could. You're going to get the exact same line. Works either way. That's the beauty of it. Just one way you're drawing the line as it goes up this way. The other way you're drawing it as it goes down that way. Same line. Slope facts. So negative 2 over 1, this is going to be a downward sloping line as we go left to right. It's going to be going down and a little steeper. So it's going to be more like this. Again, I don't have to be precise, just a quick estimate. And already I can see there, because it's starting at that -1 and then going away down to the right. This point down here, 0, -14. And also I didn't say this, but I should have, because this is a greater than or equal to, it's going to be shading above it. So it's going to be this up here. I'm be shading above it, and I'm doing a poor job shading because my little brush is so tiny. I should have changed that before I attempted this. There we go. That's a little better. But just as soon as I drew that line, and I know because it's greater than or equal to, I'm going to be shading above it, it's already eliminating those 2 points, which one of those I know was already eliminated, but it eliminates the other one, which is 0, -14. So again, 14, 0 is going to be the right answer. For most of you, I suspect that just putting it into Desmos is going to be the fastest way. But even if you choose that, you still have to know what you're looking for. It's not an automatic, Desmos can't just tell you the answer. You do have to know that when you are searching for a solution to inequalities, the inequality, the point has to be in the area where they overlap. Not the area like this might be like, oh, what about this? Because this is the area where nothing is, no color is. Maybe that's the answer. No. It has to be the area where they overlap. So D, 14, 0 is my answer. 23. Whew, lot of words on this one. Weight in pounds and frequency, and then we have this table. The frequency table summarizes the data set of the weights rounded to the nearest pound of 71 tortoises. That's kind of great. We're out here weighing tortoises. A weight of 39 pounds is added to the original data set, creating a new data set of the weights rounded to the nearest pound of 72 tortoises. Which statement best compares the mean and median of the new data set to the mean and median of the original data set? Okay, so this is a frequency table. Frequency table tells you how often something occurs within a data set. So let's say I just had a very simple frequency table that was, now I'm blanking on what I can use here. Let's say the types of fruit someone has in their house. And you have, bananas, strawberries, and apples. And you ask everyone in your neighborhood, and you find that 5 households have bananas, 10 have strawberries, and 3 have apples. That's the frequency that these occur. That's the frequency. Now, in math, these are usually numbers for this too. It's how many times the data point comes. But this is the concept that we're talking about, is just saying how often does this thing occur? That's the frequency. So here it's talking about the weights of these tortoises. So this means if we zoom in, and I'm going to cut off the answers because they really don't matter at the moment. They're just variations of sort of the same thing, like the mean is greater, but the median is less. The median is less, but the mean is greater, that kind of thing. We don't need it yet. We just need this table. So this table is telling us that there were 12 tortoises that weighed 13 pounds each, 8 tortoises that weighed 14, 5 tortoises that weighed 15, etc. So how would we go about finding the mean and the median of this data set, the original data set, before this beast of a tortoise, this 39-pound tortoise was added to the mix? A lone 39-pound. He's like twice as much as the heaviest tortoises. What has he been eating that he has grown so incredibly, impressively huge? Like, that's a monster tortoise, I'm assuming. Unless they're different species. We're not told that. Maybe they're different species. That would make more sense. I digress. I like animals. So mean is going to be, another word for mean is average. So for the mean, you add up all of the data points, and then you divide by the number of data points that there were in the set. So let's say if I had 3 data points, I would add them up, then I would divide by 3 because I added together 1, 2, 3 data points. That is my mean. Now, if you have a set of data, and it doesn't matter what's in this set, but you've got it in order from smallest to biggest, which is what we have here, smallest to biggest. Whatever this range is, in this one we're starting at 13, we're going up, we got a bunch of numbers, and then it goes up to 20. Whatever the mean of this data set is, and fun fact with this, you do not have to calculate the mean to answer this question. Please do not calculate the mean of all this to answer this question, because that's a lot. You'd be saying at the very least 13 times 12 plus 14 times 8 plus 15 times 5 and blah, 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 blah. And then going, okay, how many tortoises are there? Well, it doesn't tell us. Oh, wait, no, wait, it does tell us 71, sorry. 71 tortoises. So you'd add all that up, you divide by 71. You're like, okay, it's the mean. Now let's add this new tortoise and then do it again. Please do not do that. Please. What I'm about to tell you is what you need to know for this kind of problem. And I've seen it before on the SAT, and so I'll likely see it again. As a caveat, are there problems where you need to calculate the mean? Absolutely. They do happen. They usually do not have 71 data points, though. When it's this many data points, that should be a clue as well that there's another way, because that's a lot of time to add up 71 numbers, even with multiplication shortcuts. So here's the fact. If I have a range, if I have this data set here, and I have the lowest number, I have the highest number, and they are in order, I can identify the highest and lowest number easily. If a new number is added to that data set and it is lower than the lowest number, then the mean will go down every single time. There is no exception to this. None. Likewise, if this number is higher than the highest number in the original data set, the mean of that data set will go up. Always. No exceptions. It has to. It has to. If it's somewhere in the middle, you have to do the math. I say have to. I advise you to do the math. I'm not going to go into the sort of details as to how if it's within the middle. If you guys want to know the details about that, I might make a video specifically on that. But that's another discussion. Yeah, if you want to see that, the way to find out if it goes up or down based on that, but that normally doesn't happen on the SAT. They usually do give you a number that is either below or above the given numbers in the original data set, because they want you to know this fact that I'm telling you, that if the number added to the data set is lower than the smallest number, the overall mean will go down. If it is higher than the largest number in the data set, the mean will go up. The average goes up. Every single time, no exceptions. So in this case, we do not have to add all those numbers together and find the mean. We do not have to type anything into a calculator at all. So all this verbiage, all these data points, and we don't have to actually do math to find this answer for the first part of this. The mean's going to go up. This new mega tortoise is 39 pounds. That is definitely higher than our highest weight, which originally was 20. It's higher. The mean's going up. The mean of the new data set is going to go up. It's going to be higher than the original. All right, what about the median? The median is the midpoint in the data set when we are counting the numbers out. So in a small data set, let's say if I had 1, 3, 5, 6, and 6. The median is the number that is directly in the middle if I'm looking at the list of numbers. Like I've got 5 numbers. Which is the middle number in this group? It's 5. There's 2 on the left of it, 2 on the right of it. If you have, and that's with you have an odd number of numbers in the data set, it's the number that's directly in the middle. If you have an even number of numbers in the data set, even amount of data, then you take the 2 numbers that are in the middle, because you're trying to find what's right here. So you take the 2 numbers that are to left or right of the perfect middle and you average them. So in this case, 3 plus 5 is 8. And there were 2 numbers added, so we divide by 2 to average them, and we get 4. The median of that data set, 1, 3, 5, 6, would be 4. Okay, so we have our 71 tortoises, and we want to find the median. We take 71, we divide it by 2, and that gives us 35.5, or 35.5. So if you visualize this, saying 71, we have this big long data set, and we divided it right in half. That means there were 35, and then there was a half, and then there was another half, and then there's 35. So that half and half, that is that one number in the middle that got split in two. There's 35 numbers on the left, 35 numbers on the right, and one number in the middle got split in two, so half of that number is on each side. So that means we are looking for this number in the middle, which is the 36th number. 35 numbers, one gets split in two, 35 more. Number 36 in this lineup is going to be our 1. So let's look at our frequencies. We start at the top and we go down until we see where would number 36 be. All right, so 12 plus 8, that's 20 numbers in those first two. Another 5, now 25 numbers. Another 7, 32 numbers, okay. And then there's 9 more. That gets us up to 41. So there's 9 numbers here that are 17. And that 36 number is right smack dab in the middle of that. So it's like number 33 is 17, the 33rd number. The 34th number is 17. The 35th, 36th, 37th, all the way up to the 41st. The 41st number are 17. So the number we want, the 36th number, is 17. All right, so the median is 17. Now when we add one more number on the end of this, what's going to happen to that median? Well, we no longer have 72 numbers. Excuse me, we no longer have 71 numbers. We have 72 numbers. 72 divided by 2 is 36. So now we've got 36 numbers on the left, 36 numbers on the right, and there is no number in the middle that's getting split. So we need to find the two numbers on either side. This would be the 36th number and the 37th number. Well, when we add one more number on the end, it doesn't change what the 36th and 37th number are, correct? It just changes what the 72nd number is going to be. So we already know that the 36th number is 17, and all the way up to the 41st number is 17. So that means also my 37th number is 17. Well, we've got our two numbers and we need to average them together. Well, when we average 17 and 17, we just get 17. If you average two numbers that are the same with each other, you just get that same number again. 17 plus 17 divided by 2 is 17. So the median doesn't change. If this was a whole string of individual numbers, like if there was only one turtle at each weight, the median would change in that case. But in this one, it doesn't, because we got 9 turtles here in this range from the 32nd to the 41st turtle. So that median is not changing. So our final answer here is that the mean is going to go up, but the median is not going to change. So let's see which answer says that. The mean of the new data set is greater. Yep, that's right. And the median of the new data set is greater. Nope, the median is not. That one's out. B, the first part, the mean of the new data set is greater. Yes. And the medians of the two data sets are equal. Ding, ding, ding. Double check just to make sure there's not a trick in here. C, the mean of the new data set is less. Nope, we're out already because it's not less. And D, the mean of the new data set is less. Nope, not at all. All right, so B, there is my answer. But yes, please, for the love of all that is good on the SAT, do not find that mean manually. Please, please, please memorize the rule that says if you have a data set and you know the lowest and the highest number, if you add a number to that data set that is lower than the lowest, the mean goes down. If you add a number that is higher than the highest, the mean goes up every single time. Please remember that. 24, x minus 29 equals x minus a times x minus 29. Which of the following are solutions to the given equation where a is a constant and a is greater than 30? Is a solution, a plus 1 a solution, or 29 a solution? All right, and at least one of them is a solution because look at our options. 1 and 2 only, 1 and 3 only, 2 and 3 only, or 1, 2, and 3. Okay. Are there any that are in all three of these? No. 1 is in A, B, and D. 2 is in A, C, and D. And 3 is in B, C, and D. So there isn't any one of these options that's in all 4 choices. So we have to look at all 3 of them. If it was in all 4 choices, then we would automatically know it's right? So like, oh, it's in all 3 answers. I don't have to look at it, but we need to look at all 3 of them. Okay, so what is a solution to an equation? What is it? A solution to an equation is where it crosses the x-axis. It could be, like if it's a line, that would be our solution to the equation. More commonly, you have things like this. You have a quadratic, and those are your 2 solutions to the equation. You can have a cubic, which can have 1 solution. It can have up to 3 solutions. It can have 2 solutions. It's just where it crosses that x-axis. The 3 or 4, I'm trying to remember the number. I get the number wrong. But here's all the ways that they say this concept. They say the x-intercept. They say the solution to the equation. They say the zeros of the equation. And there's one more that's eluding me. Oh, yes, they'll also say, where does y equal 0? That's another way they phrase it. Less common. They usually say, what's the solutions to the equation, the zeros of the equation, the x-intercept. Those are the most common when it's a single equation. All right, so here we have x minus 29 equals x minus a times x minus 29. Let's look at that. And we could distribute this, and we may need to, but first let's look at it without distributing anything. Just don't know if we need to yet, right? Just if we don't have to, let's not. But what I do want to do is I want to move this all over here so that it's all equal to 0. Because if you remember, like when we're doing quadratics, we always want it to be equal to 0. Like, x squared plus 5x plus 6 equals 0, and then we can solve for x. In that case, if you replace that 0 with y, so you're saying where y is 0, then you look at the graph and you go, where does it cross the x-axis? See, it's all connected. So let's move this x minus 29 over here so we've got 0 on the left. So to do that, I'm going to add 29 to both sides. And then I'm going to subtract x from both sides. I'm going to do this all in one fell swoop. So I've got 0 equals x minus a times x minus 29. And then I've got that minus x plus 29. Okay, now I'm going to get rid of this original. And come on, there we go. It really does not like it when there we go. Oh my goodness gracious, there we go. Woo, and like spazzed out there for a second. Like, no, you shall not grab things and move them. I'll do what I want to do, whiteboard. Right, let's look at our 3 answers. We have a plus 1, and 29. Which of these things, if I were to plug them in here, would give us an answer that's going to be 0? Which one would give us 0? Okay. So you're like, okay, can I figure this out without distributing? Let's see. Let's try our number 29 here. What if I put in 29 for x? Because that's what we want the solution. X is what we're plugging these things in for. We're plugging these in wherever there's an x, okay? That's the idea. I should have mentioned that earlier. I'm sorry. So let's try 29 first. Okay, so first, if I plug 29 in, I'll get 29 minus a times 29 minus 29 minus 29 plus 29. Okay, this looks interesting. The 29 minus a, I don't know what a is. I know it's a constant greater than 30. So it's greater than 30, so 29 minus a is going to be a negative number. So I just know that's a negative number. But this 29 minus 29 is 0. So a 0 times this negative number is going to be 0. And then it's minus 29 plus 29. 0 minus 29, then plus 29 is just 0. Okay, so 3 works. So already I know A is out. That says 1 and 2 only. It must be B, C, or D. Okay, so let's try one of these others. Let's try if x is a. All right, so a minus a times a minus 29 minus a plus 29. Okay, so a minus a is 0. Then I have a minus 29. I don't know what a is, but I know it's, greater than 30. So I know this is a positive number because it's greater than 30. So 31, for example, minus 29 would be 2. It's a positive number. And as a gets bigger, it's still going to be positive. Okay, but 0 times a positive number is just 0. And then minus a plus 29. Well, I know a is greater than 30. So if I'm subtracting a number greater than 30, let's just plug in 31, and then plus 29, is that going to be equal to 0? Never. It never will. A would have to be 29 for that to work. So, okay, so it can't be just A. Doesn't work. All right, so any one that has this as an option can't be right. So it's not B or D. It must be C. So let's see if this is correct. Let's see, we've done it right. Let's see if 2 works, just as a check. Just as a check. Let's see if 2 works for this. So a plus 1, we plug that in wherever there's an x. So a plus 1 minus a times a plus 1 minus 29 minus a plus 1, okay, plus 29. All right, so this one, a plus 1 minus a, those a's cancel out. I'm just left with 1. 1 times, and here we have a plus 1 minus 29, or a minus 28. And I wrote 29. Shame on me. So 1 times a minus 28 is a minus 28. And then I have here minus a plus 1. So we change that to plus, minus, minus. All right. So when we have negative a plus negative 1 plus 29, a and the negative a cancel out. Change all these to plus and negative to make this a little easier to see. So a plus a negative a is 0. Then negative 1 plus 29 is 28. And I keep writing 29. Shame on me. 28. I wrote that 8 weird. There we go. Then negative 28 and positive 28 together are also 0. 0 plus 0 is 0. It works. There is another way to do this. You might be going like, after you took me through that long roundabout way, now you want me to show you another way? Yeah, I actually want to show you the way that the College Board told you to do. So yeah, so again, the way I did it is I thought it was easiest to plug in 29 and A. So I did those. I found that 29 works and A does not. So the only answer it could be at that point is C, because it's the only one that doesn't have a 1 in it. And honestly, if you started with A, if you went down the list, from the top and you just plugged A in, I mean, I picked 29 because I thought it looked easier at first because I'm like, oh, 29 going in there, that's going to be 0. That might be fun. But, if you plug A in there, you also get a 0 there. So if you had started at the top, plugged in A, and then tried it and see if it worked, you would know, and then you're like, okay, A does not work. A, B, and C are out because they all have A. C must be your answer. Yes, I want to explain the way that the College Board explains it. Just so if you're looking at it going like, what is it talking about? Hopefully I can shed some light on it. It's a little interesting, and I expect some people to have questions. So they started by doing the same thing I did where they moved that x minus 29, but they moved it as a unit. Okay. So they have an x minus a and that x minus 29, and have it equal to x minus 29. And then they subtract the whole thing together. Instead of treating it like I did where you add the 29, subtract the x, they treat it as a unit. And so they say minus x minus 29 minus x minus 29. Subtract it on both sides, and then you get 0 is equal to x minus a times x minus 29 minus x minus 29. Now, this is where it gets a little unusual, I think, for some people. Now they treat it like they're factoring this like grouping. So when you are factoring by grouping, it's when you have, let's say, x times, x minus 5 plus 3 times x minus 5. You can change that to x plus 3 times x minus 5. Now to go a little further to explain why that's true, why that works, is if you have, it's like if I had, and I'm going to get this totally out of the way for a second and really just look at this math concept. If I had 2 x's and I added 4 x's to them, how many x's do I have? I have 2 plus 4 or 6 x's, right? I added 2 plus 4, and that's how many x's I have. That's what's going on right here. So if I have x minus 5s, and I add 3 more x minus 5s, I have x plus 3 x minus 5s. So that's the concept. Now, they used that, and they looked at this x minus a, x minus 29, all that, and they viewed it like they were grouping it and factoring it, and said, this over here, this negative x minus 29, is the same as negative 1 times x minus 29. So now I have x minus a, x minus 29s, and I have negative 1, x minus 29, so I can factor by grouping. So that makes it x minus a minus 1 times x minus 29 equals 0. And then they started plugging things in. Yeah. That's such an unusual, I think, way of looking at it, and I don't think it's a way that most students are going to immediately see or understand that that's where they're going, and I totally get it if they don't understand that that's where they're coming from. But once they got to that point, then they can plug things in pretty easily. So they plug in, like 29, and actually, if I think correctly what they did, actually, let me take that back. They didn't just plug things in at that point. I'm pretty sure that they viewed them each as like we would if we are factoring, like he set each one equal to 0. So either x minus 29 equals 0. You know how when you factor and you get like x minus 2, x plus 3, and you set them both separately equal to 0? They did that. So it's like x minus 29 is equal to 0, and then also x minus a minus 1 is equal to 0. So when x minus 29 equals 0, you add 29 to both sides. And my writing is not the greatest on any normal day, but I'm blaming my cat. She is climbing all over my desk. And she is an elderly kitty, and she's not doing that well, so I'm inclined to let her do whatever she wants. So I apologize for that. So if we add, but she is keeping me from writing clearly. Dee-da. If we add 29 to both sides, we get x is equal to 29. So 29 is one of the zeros. That would be 3. And then this one, x minus a minus 1 equals 0. You can solve for x, and I'm actually going to bring this all over here. X minus a minus 1 equals 0. To solve for x, I'm going to add 1 to both sides, and you get x minus a equals 1. And then we add a to both sides, and you get x equals a plus 1. And so 2 and 3 are the answers. Yeah. So yes, even if you had gotten to this point, like they did, and factored by grouping, you absolutely could at that point plug in these 3 and see which one, get you the answer. Same difference. If I plug in 29 there, I get 29 minus 29, or 0, and 0 times anything is 0. If I plug in a plus 1 there for x, then this is here going to equal 0, and again, 0 times this is 0. So either way, it works out. Number 25. In the xy plane, the graph of the equation y equals negative x squared plus 9x minus 100 intersects the line y equals c at exactly 1 point. What is the value of c? Right. I tend to like doing this as a not using a graph. So I will show you why I like that. if I have a parabola, this is our basic y equals, x squared. This one, we got a little extra. It's a negative x squared plus 9x minus 100. The fact that it's a negative x squared means that it's going to be opening down. And I don't really know how wide or how narrow it is or where on the graph it falls. I absolutely can graph this and take a look at it. But if there's a line that intersects it at exactly 1 point, what is this value? And it's y equals c. So y equals c, y equals a number is a horizontal line, because we know c is a constant because those are our only options, our constants. So where in this parabola would a horizontal line cross it and intersect it at only 1 point? This would only happen at the vertex. This horizontal line has to be coming along and just barely touch it right there. There we go. That's pretty good. That only is touching it just at that 1 point. Anywhere else, it's going to touch it at 2 points. So it has to be going through the vertex. So there's 2 ways that you can do this. Once you know that, you can go over to Desmos and you can find out what the vertex is. And it's likely to be a fraction because 3 of these out of the 4 are fractions. You can find what that y value is at the vertex. And then you can convert it to one of those 2. Absolutely, you can do that. Another way you can do this is that you can figure out what that vertex is mathematically. Either way. The way to figure out the vertex, my favorite way, is to first find the axis of symmetry, then plug that value in to this equation, and you'll get your answer. The axis of symmetry, it's a vertical line, so it's always going to be x equals, and it's x equals negative b over 2a. If you don't have that in your memory, in your database of knowledge for the SAT, it's a good one to have. And that x equals negative b over 2a for the axis of symmetry. And the a, b, and c, anytime we have this a, b, and c with quadratics, ax squared plus bx plus c, that a there is referring to the number in front of the x squared, and the b is referring to the number in front of the x. C comes into play when we have like the quadratic formula. But for axis of symmetry, it's just a and b. So here in the y equals negative x squared plus 9x minus 100, and I probably should have written that. Let's write that a little over here. Oh yeah, y equals negative x squared plus 9x minus 100. So negative b over 2a, that negative means the opposite, not just make it a negative, but here it is a positive 9 is b, so the opposite of that would be negative 9. And my a is a negative 1, so 2 times negative 1. So negative 9, boop, boop, and 2 times negative 1 is negative 2, so negative 9 over negative 2, or just 9 halves, because those negatives cancel out. Then you take that 9 halves for your x and you plug it into this. Wherever there's an x, you plug it in. So we got this down here. We have 9 halves squared, we take a negative, plus 9 times 9 halves, and then we subtract 100. So 9 halves squared, 9 halves times 9 halves, you square what's on top and square what's on bottom. 9 squared is 81, 2 squared is 4, and this is a negative, so negative 81 fourths. Then plus 9 times 9 halves, 9 times 9 is 81, because when you multiply fractions like that, it's same as 9 over 1 times 9 over 2. So 9 times 9 on top is 81. 1 times 2 is 2. And then we subtract 100. So to combine these fractions, negative 81 fourths, 81 halves, this needs to become fourths. So to change that to fourths, we need to multiply by 2 over 2. That will make the bottom fourths. 81 times 2 is 162. 162 fourths. So negative 81 fourths plus 162 fourths is 81 fourths. And then we're subtracting 100 and 100. And I realize I am running out of room and I'm I'm showing my next problem. Let's scoot that over. There we go. So 100, convert that into fourths would be 400 fourths. We get that by multiplying 100 over 1 times 4 over 4. So 81 fourths minus 400 fourths is equal to negative 319 fourths, which is C. So could you do this by graphing? Yes, let's go look at doing it by graphing. Okay, and we're going to have to zoom way out to be able to see it out. And there it is. So we go there, and sure enough, it is, there's our y value, negative 79.75. So negative 79.75. We go back over here. If you use the graph, once you have that number, negative 79.75, you just need to determine which of these is equal to that. And when you convert that, you're going to get C. So is that a lot quicker? Yes, it is. Either way, we definitely have to know where are we looking. When we say the line y equals C intersects at one point, we know it has to be a horizontal line that intersects it at the vertex. So we need to find that vertex. Once you know that, once you know I need to find the vertex, frankly, looking at the chart and then saying, okay, I'm at the graph, and then saying negative 79.75, which of these does it equal, is the faster way. All of this that I did, this, I don't ever want to say just, it happens, but I don't like saying just, oh, just put it in Desmos, because a problem may come up that you need this information and Desmos won't cut it. It does happen. So anyway, that's how you do all that. But yeah, for this one, I go to Desmos and get C, negative 319 fourths. Number 26. The functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? We have function 1, f of x equals 18 times 1.25 to the power of x plus 41. And function 2, g of x equals 9 times 0.73 to the power of x. So these are exponentials, a number to the power of x. Immediately, we want to be thinking Desmos. Don't try graphing this by hand. Is it possible? Of course, anything's possible. Don't do it. But what does this question mean? What are they asking us? As a constant or coefficient? Get used to this, because boy, do they love questions that ask this. Which of these questions displays blah, blah, blah as a constant or coefficient all the time? A constant is a number that doesn't change. 5 is a constant. Negative 22 is a constant. 1,000 is a constant. 1/4 is a constant. A constant is not a variable. It's a flat number. It doesn't change. A coefficient is a number that is multiplying by something, like 6x. 6 is my coefficient. X is being multiplied by it. So when we look at these equations and look for constants or coefficients, you're just looking at the numbers, the plain numbers. So what are my plain numbers in f of x? My plain numbers are 18, 1.25, and 41. Those are my constants or coefficients. In my second one, g of x, my plain numbers are 9 and 0.73. Those are my constants or my coefficients. Now, okay, so it's saying which of these displays the maximum value of the function it defines. Now, when we talk about maximum values, a lot of times we're thinking of things like parabolas. We have, an upside down, a downward facing parabola. We have a maximum value there. That is the vertex. It's the highest that it goes. Some functions do not have maximums. A line does not have a maximum. It goes up and up forever. A cubic does not have a maximum. It goes up and up forever. Exponentials do not have maximums. Exponentials can come in 4 different varieties. They can look like this, like this, like this, or like this. Those four main, that's your varieties of, exponentials. So like in this case right here, they're going down, to the left, and they're going up forever to the right. This one, they're going up forever to the left. Here, it's not going up, up, up forever. It's approaching a limit, but it never crosses that limit. So there isn't a strict maximum point. It gets close and close. It'll say the limit. And same with this one. It goes up and up and up, and there's a limit. It never touches that limit. It gets closer and closer and closer, but there isn't a true maximum point. And likewise, there's no true minimum point. So how could they ask this? How could they ask what's the maximum or minimum of this function? It's right here, where x is greater than or equal to 0. That's the only part of this we're going to look at. So let's go over to Desmos and look at these two. And here we go. We have f of x here in red and the g of x that's going up to the right, and we have g of x in blue that's going down to the right. They're both approaching their limits, and they're also going up into infinity, just in different directions. So this one's approaching a limit, looks like it's 41. It's approaching 41, and it's going up into infinity. This one here goes up into infinity negatively to the left, and it's approaching 0 to the right. Yes, I know it says 0 over there. It's not actually touching 0. It just gets so small that Desmos isn't registering it, but it doesn't actually touch 0. Limit fact. All right, so when x is greater than or equal to 0, let's just move it over. So we're only looking at that bit. What are the maximum values of this thing? What's the maximum value of this where x is greater than or equal to 0? There isn't one, because it's going up and up forever, right? When x is greater than 0, there is no maximum. It just goes up forever. Now, our g of x, our blue one, when x is greater than or equal to 0, there is a maximum point. This is the highest that it gets. It's 0, 9, and then from there it goes down, and it goes smaller and smaller towards that limit of 0. But yeah, it has a maximum point. When x is greater than or equal to 0, the maximum point is 9. And is 9 anywhere in here as a plain number, as a constant or coefficient? Yes, it is. Right there. So f of x does not have a maximum, so there's no number to compare to see if the maximum matches any of its constants or coefficients, because the maximum doesn't exist. And then here, the maximum does exist. It's 9, and sure enough, there is a 9 right there. So g of x is the only one. So let's go back to our thing here. Okay, so what are our options? We've said that it is not the case in number 1, but it is the case in number 2. Our options are 1 only, that's not true. 2 only, that looks like our right answer. 1 and 2, nope. Neither 1 nor 2, nope. There we go. B is my answer. Number 27. The perimeter of an equilateral triangle is 852 centimeters. The 3 vertices of the triangle lie on a circle. The radius of the circle is w square root of 3 centimeters. What is the value of w? Right, couple of things right off. I'm always going to draw what I am given first. So I know I have a triangle, an equilateral triangle, and it's inside a circle. So, okay, I got my circle. And let's see if I can pull this off. I'm going to have... Come on. That's not bad. It's not the best triangle I've ever drawn. It's not a perfect equilateral, but it is close enough that we can know what's going on. Right, so the 3 vertices lie on the circle. And what are we given? We are given the perimeter of the triangle. We know that that's 852 centimeters. And we know the radius of the circle is w square root of 3 centimeters also. Right, so what do I know about equilateral triangles? Equilateral triangles all have congruent sides. They're all the same. They also have congruent angles. Each one of these angles is 60 degrees. These are equilateral triangle facts that you definitely should know. If you didn't have that in your data bank, please add it there. Remember it for the SAT. Comes up a lot. Okay, so I have this triangle. Do I know anything else about it? Well, I know its perimeter is 852. Because of that, I can figure out the length of each side. All 3 sides are the same, so 3 times the length of one side would be 852. So to solve for that, s is being multiplied by 3. So I want to undo that. I want to divide by 3. So I get that S is equal to 284. So 284 centimeters is the length of each side. Okay, that's good to know. Now, when they tell us the radius of the circle is W square root of 3, anytime you have a triangle and you have square root of 3, you have a problem with a triangle and square root of 3 is mentioned, I want you to immediately think, is there a way I can use 30, 60, 90 triangles? Have that pop up in your head. You may not, but the odds are in your favor. It's going to be a 30, 60, 90. Just the way it works. Now this pattern that's we have observed in the 30, 60, 90 triangles that they ask you to memorize, it is provided by the SAT board, the college board. You can see it, but you have to know you need it. And that's why I ask people to memorize it. Because if you memorize it and you know what's in it, then you are more likely to recognize when you need to use it. Trust me on that. So the pattern is like this. The leg that's next to the 60, you can represent with X. The hypotenuse is 2 times that number, or 2X. And the leg next to the 30 is that number times the square root of 3. And that's the pattern it follows. Likewise, if you see square root of 2 related to triangles, I immediately want you to think of 45, 45, 90 triangles, which are A, square root of 2. Those are the patterns, and it's just really good to have those in your head so that, again, when you see a square root of 3, a square root of 2, your mind's going to go to that and see, can you use it? And a lot of times you can. All right, so we're looking for 30, 60, 90 triangles. We don't have it yet, but we do have these 60 degrees. And what happens if I draw some radii in here? So that's about the center of my circle. So if I draw a little radii out to the corners, it's rough drawn, but you get the idea. What am I doing? I am dividing this triangle into 3 congruent triangles, 3 congruent smaller triangles. And I'm also splitting each of these 60-degree angles in half. So now I've got each of these is going to be 30 degrees. Each of those is 30. And this is true all the way around. Each of these little angles is 30 degrees. But I still don't have a 30, 60, 90 triangle, do I? Not yet, but I'm getting there. I'm getting close. I've got 30s now. I have bigger triangles that I can make, this big triangle that has 60 degrees. What would happen, I'm going to use a different color for this. Let's say, what would happen, let's go orange. If I extended these radii, it doesn't look that different, does it? Let's use baby blue. That'll be different. Okay. What would happen if I extended these radii? And if I had drawn this all perfectly? Well, then I have split those triangles yet again. I've cut them in half. So it should be 6 congruent triangles now. Instead of 3, I've cut them all in half. And each of these I've drawn, these are altitudes, meaning it's creating a right angle here. It's an altitude for this triangle, an altitude for this triangle, an altitude for that triangle. So it's creating right angles. And now, my friends, we've got our 30, 60, 90 triangles. So like, for instance, if I just looked at this triangle right here, I can see I've got my 30 degrees right there, got my 90 degrees. So the other remaining angle must be 60 degrees, always. Do I have any lengths of these sides? Well, I know the radii are all 3 square root of 3. So this particular radius, not 3 square root of 3, W square root of 3. Oh, forgive me. W square root of 3. And do I know the length of either of these 2 sides? Yes, I do. I know the length of this side because I know this whole thing is 284 and I just cut it in half into 2 equal bits. So 284, divide that by 2, and I get 142. So now I have this smaller triangle, which is a 30, 60, 90 triangle, and I know one of the sides is 142. Once I have a number, any number, I can determine all three sides using this formula. So I'm going to bring this down over here. I'm going to keep it just like it is. So there's my 30 degree. There's my 60 degree. This side is 142, and this side is w square root of 3. Right, so does it fit this little thing? Yes, it does. How does it fit it, though? We have to be very careful. We don't want to just see this square root of 3 and think, oh, that's that side. It isn't. We have to go by where the side is relative to that right angle. This w square root of 3 is the hypotenuse. It's correlating to the 2x. This 142 is correlating to the x square root of 3 because it is the leg, that is, it's touching the right angle. Those are the two legs, the ones making the right angle, and it's the leg that's touching the 30 degrees and the right angle. That's how I always remembered it, is it's the square root of 3 is the leg with the 30. That's how I connected it. Yeah, this one has to be the smallest because it's just x. Here you're multiplying it by x times a number which is smaller than 2. And then this would be the biggest number, x times 2. So the biggest number would have to be the hypotenuse. Okay, where do the other two go? The square root of 3 goes by the 30. That's what helped me remember that. All right, so that 142 is x square root of 3. So I need to solve for x. Well, let's do that then. So we'll say this over here, that x times the square root of 3 is equal to 142. I need to undo what's been done to x. X has been multiplied by the square root of 3, so I need to divide by the square root of 3. Now I get that x is equal to 142 divided by the square root of 3. We cannot leave a radical in the denominator. It is not allowed. You go to math jail. Not really, but your teacher gets very mad and you get the answer wrong. So we have to get this radical out of there. How do we do that? We're going to multiply by that radical over itself. Two reasons for this. One, any number over itself except for 0 is equal to 1. So square root of 3 over square root of 3 is equal to 1. And we can multiply any number by 1 and not change it. That is the identity theorem. A little rusty on that name. Pretty sure that's it. You can multiply a number by 1 and it won't change it. So, okay, I'm not changing anything by multiplying it by square root of 3 over square root of 3. And when I do this, this on the bottom is going to get rid of the radical because the square root of anything times that square root equals the original number. Works for any number. You know, like square root of 78 times square root of 78 is just 78. So when I do this, on the top, I am going to get 142 times the square root of 3, and the bottom, square root of 3 times square root of 3 is just 3. So now I look and see, can I simplify this any further? Does 3 go into 142? It doesn't. Quick little way to do that is you can add up the numbers that make up a number. 1 plus 4 plus 2, that's 5. 7, is 7 divisible by 3? No, then the whole big number is not. Shortcut, multiplication. That's this little, yeah. So I can't simplify this any further. It is what it is. So this is 142 thirds times the square root of 3. That's my x, because this could be square root of 3 over 1, and that's why I can pull it to the side. So 142 thirds square root of 3 is, that's my x. That's my x. So then what is this over here, which is the hypotenuse, these two being the same? I know my x is that, so my hypotenuse is 2 times x. Okay? That's x. What's 2x? So I need to multiply this by 2 to find out what 2x is. So 2 times 142 thirds times the square root of 3. So 2 over 1. 2 times 142. Well, we actually already know what that is because we divided 284 to get to 142. So 2 times 142 is 284. And I just keep running out of room. It just keeps getting smaller and smaller. And 284 divided by 3 times square root of 3. And is 284 thirds divisible by 3? No, it is not. Same little trick. 2 plus 8 plus 4 is 14. 14 is not divisible by 3, so it's not. So that's it. That's my hypotenuse. My hypotenuse is 284 thirds times the square root of 3. So when they said the hypotenuse, which we mentioned is the radius of this circle, it's both. The radius is W times the square root of 3. What is W? W is 284 thirds. That is your answer. And you can also write this as a decimal. The College Board will accept either 94.66 or 94.67. Yeah, there's a lot there. And this is one of those problems that I can't really see a way that Desmos, like graphing or something like that, would be of much help. It really is relying on your knowledge of 30, 60, 90 triangles and radii and inscribed triangles and all that good stuff, and how to use that to solve. There you go. 284 thirds is your answer, and you have reached it. You have made it to the end. Congratulations. Hey guys, it's Alyssa, and if you're looking for more SAT or PSAT prep, go to mathwithalyssa.com. There you can get over 25 hours of test prep, including math and reading and writing. That's not available on my YouTube channel, just over there, along with practice questions, downloadable study guides, and more. Links to everything you need are down in the description below. If you have any questions or suggestions for what a future video should be about, leave those in the comments below. And if this video was helpful or useful in any way, please like, share, subscribe. You know the drill. Let that YouTube algorithm know it helped you. Thank you so much for watching. Hope you have a great day. See you later. Bye.